A circuit consists of a resistor of 500 ohms and a capacitor of 5 microfarad connected in series. If an alternating voltage of 10 volts and frequency 50 hertz is applied across the series circuit, calculate the reactance of the capacitor, the current flowing in the circuit, the voltage across the capacitor. The capacitor is replaced with an inductor of 150 millihenry. Calculate the impedance and voltage across the inductor. A situation of this question can be shown in this diagram. We have a resistor connected to in series with a capacitor, and this connection is connected to an AC source. The source voltage is 10 volts, and we have the frequency as 50 hertz. From the question, the resistor is 500 ohms. Capacitor is 5 microfarad. The first question asks here for us to find the reactance of the capacitor. The capacitance of the capacitor is given as 5 microfarad, the same thing as 5 times 10 raised to the power minus 6 farad to the SI unit. So the reactance, capacitive reactance, will be given by XC, which is 1 over 2 pi, the frequency times the capacitance. Substitute the value, we have 2. We use pi as 3.142. The frequency is 50. Then we have the capacitance, which is 5 times 10 to the power minus 6. Using the calculator, that value, we have the value to be given as 636.6 ohms. That should be the value for the capacitive reactance of the capacitor. The next question, the current flowing in the circuit. The current flowing in the circuit will be given by the expression the root mean square current will be equal to the root mean square voltage all over the impedance of the circuit. The impedance. Here we have to find the impedance. The impedance of the circuit is given by the expression the square roots all over square roots. We have the resistance square plus the capacitive reactance square. Putting the values, the question here, we have the resistance to be 500. Reactance will be calculated as 636.6. Square that. Using a calculator, the impedance of the circuit is given as 809.5 ohm. 809.5 ohm. We need to find the current. The root mean square current is equal to the root mean square voltage all over the impedance. That means the root mean square voltage is 10. The impedance is 809.5. That will give us the root mean square current of 12.35 milliampere. If you use the calculator, you obtain that value. We also asked to find the voltage across the capacitor. The voltage across the capacitor, that would be VC, given by the expression the current multiplied with the capacitive reactance. The calculated current here we have, calculated current is 12.35 times 10 raised to the power minus 3. Multiply with the value of the capacitive reactance, which we calculated here, is 6. That is 636.6. Using a calculator, we'll have the value for the voltage across the capacitor will give us approximately 7.86 volts. The last question, but to find if the capacitor is replaced with an inductor of 150 millihenry, that the inductance is given as 150 millihenry. We have to find inductive reactance given by 2 pi FL. 2 pi FL. 2 pi is 3.142. The frequency is 50. The inductance is 150 times 10 by minus 3 in terms of the SI unit. The inductance, the inductive reactance will give us 47.12 ohms. With that, we can find the current, getting the current. The root mean square current will be equal to the root mean square voltage all over the impedance. Root mean square voltage is given from the question 10 volts. The calculated impedance is given as 809.5. Using the calculator, the root mean square current will be given as 19.9 milliampere. That is the value we have.